everyone, thank you so much for clicking onto the video. Today's learning objective is to do with the mole, and we're going to explain and use the terms amount of substance, mole, the Avogadro constant, molar mass, and also molar gas volume. So now I'm going to introduce the mole. And firstly, we need to define amount of substance. So the definition is the quantity whose unit of the mole used as a means of counting any species, such as atoms, ions, or molecules. And the mole is a unit which chemists use to measure the amount of a particular substance. And 1 mole of any substance contains 6.02 times 10 to the power of 23 particles. And this is Avogadro's constant. And so the definition of Avogadro's constant is the number of atoms in 12 grams of carbon-12. And so there must be 6.02 times 10 to the power of 23 carbon atoms in 12 grams of carbon-12. And it's really important to understand what you're measuring. So be careful with diatomic molecules. So for example, if we had 1 mole of hydrogen molecules, which has the formula H2, we'll have a mass which is twice that of 1 mole of hydrogen atoms, because we only have 1 hydrogen atom instead of 2. And the definition of molar mass is the mass of 1 mole of a substance. And the molar gas volume is the volume per mole of gas molecules at a stated temperature and pressure. So we're going to look at a quick example, which is to find the number of sodium plus and oxygen 2 minus ions in 1 mole of sodium oxide, and to find the molar mass of an oxygen molecule. So what we have is this sodium oxide, and we can split this up into sodium plus ions and oxygen 2 minus ions. Because for every mole of sodium oxide we have 2 moles of this Na plus ion, and we have 1 mole of O2 minus ion. And so to work out the number of ions in 2 moles of Na plus, we have to multiply 2 by Avogadro's constant, because Avogadro's constant is the number of ions we have in 1 mole, and we have 2 moles. And so we do 2 times 6.02 times 10 to the power of 23. And so this gives us 12.04 times 10 to the power of 23 ions. And then for the O2 minus ions, we only have 6.02 times 10 to the power of 23 ions, because we would multiply Avogadro's constant by 1. And then for finding the MR of oxygen, what we have is that MR of oxygen is equal to 2 times 1 oxygen atom. And so we'd have 2 times the relative atomic mass of oxygen, which is 16.0. And so this would give us 32.0 as our molar mass for oxygen. And one really important note is that this molar mass is measured in grams per mole. So we have grams per mole. And also this molar gas volume is measured in deciliters cubed per mole.